Hello and welcome. In today's class, we will see how we can write a Java program to solve the even number program. This question is taken from ISC Computer Science 2020 Specimen practical paper. So according to the question, an even number is a positive whole number which has even number of ones in its binary equivalent. Let's take an example. Consider the number 9. The binary equivalent of 9 is 1001. Now 1001 contains even number of ones. Thus, 9 is an even number. A few even numbers are 3, 5, 6, 9 and so on. So in this question, we have to design a program to accept a positive whole number n where n should be greater than 2 and less than 100. Now find the binary equivalent of the number and count the number of ones in it and display whether it is an even number or not with an appropriate message. Here are some examples. If we take n as 15 as input, then its binary equivalent will be 1111. So there are 4 ones, even number of ones, and that's why it will display even number. This is another example. Here n is 26. Now the binary equivalent of 26 is 11010 and we have all total 3 ones here, which is odd. 3 is an odd number and that's why this is not an even number. 26 is not an even number. And when number 145 is entered, it displays number out of range because it is crossing the limit that was mentioned in the question. So once our question is clear, we can begin writing the program. So let's start. So here I have created a file evil.java. Let's start with the import statement. Then the class. We create the main function. Inside main, we create the scanner object. Now we ask for the value of n. So int n equals integer.parseInt in.nextLine. Once we have taken the value of n, we need to check whether it is in the given range or not. So we write if n is less than 3 or n is greater than 99, in that case we print number out of range. And then we call the return keyword to exit from main in case the number is not in the given range. Otherwise, we find the binary equivalent using a user-defined method, let's say convert to binary. We pass the value n here. And once the binary equivalent is calculated, we can find the number of ones in it using another method, let's say count ones, and we pass the binary number in it. Later, we check if count is even or not. If so, then we conclude that it is an even number. Else, we print not an even number. Now the main function is complete. Let's create the remaining 2 methods. public static int convert to binary int n. Now we take a variable b. This is where we will be calculating the binary equivalent. And we take a variable p which will be initialized to 0. So later it will be clear why we are taking this variable. So while n is greater than 0, we extract the binary digit by doing n modulus 2. This is our binary digit. And we form the binary number using the formula b is equal to b plus int of mat.pow 10 comma p plus plus into d. So basically what we are doing over here is p is starting with 0. So 10 to the power 0 means ones place. 10 to the power 0 is 1. So in ones place, we put the first digit. And because this is post increment, later p will become 1. So 10 to the power 1 means next digit will be for the tens place. And then when p becomes 2, it will be for the hundreds place and so on. So that's how each and every digit will be placed in the right position. And we also reduce n each time by dividing it by 2. So this is how we can generate the binary equivalent. Once the loop is over, for clarity, we print the binary equivalent as b, and then we return b. Now only one function is left, count once. So public static int count once int n. Now here we take a counter initialized to 0. Now while n is greater than 0, we extract the digit n modulus 10. Now we check this digit. If this digit is equal to 1, then in that case count plus plus. And at the same time we also reduce this number by dividing it by 10. And again for clarity we display how many digits are ones here. So we write number of ones is C, and then we return C. So that's all. We have completed our program. Let's save it and check the output. So first of all, we compile it and then we execute. So when I'm giving the value 15, it is showing that the binary equivalent is 1111 and it consists of 4 ones. That's why 15 is an even number. If I give n as 26, the binary equivalent is 11010. Number of ones is 3, and that's why it is not an even number, because 3 is an odd number, it's not an even number. And when I give n as 145, it shows number out of range because we have crossed the limit that was mentioned in the question. So that's how we can solve the even number program. I hope I have made it clear to all of you. Thank you for watching and see you very soon in the next class.